So Fabrice decided to change the title of my talk. I'm going to change it back to the original. So this is what I usually call this talk. Anyway, my name is Igor. You might know me from projects such as Silex, Symfony, Composer, React PHP, YOLO PHP, Stack. And there is a conspiracy. But before we get to that, we need to cover some basics. So, the title of this talk is The HTTP Kernel Interface is a Lie. Who uses Symfony? Okay, so that's about 70%. And of those, who knows what the HTTP kernel interface is? Or has heard of it? Okay, so about 50% of those. So let's start with some basic terminology. What is an actual interface? And when you hear this word interface, what you generally think about is a language construct. Because in PHP, we have classes, we have interfaces, classes can implement interfaces, but that's not really what an interface is about, because it's more about the underlying concept than a specific language construct. A different word for interface would be a protocol. So protocol defines rules for communication. It defines which types of messages can be exchanged between two parties, which could be two objects in a system, or it could be two nodes in a network. So I'm not talking about protocol specifically in the network sense, but as a general concept. So an interface and object-oriented programming in general is really about communication. It's about objects communicating. And if you go back to the roots of object-oriented programming, then they're not really talking about methods, they're not talking about language constructs, but they're talking about objects that exchange messages, that send messages. So that's how I want you to think about what an interface is. It's about message passing. So take Bob, for example. Bob is happy because he's walking down the street and he walks into this cute girl called Alice. And he says, "Hi." And Alice responds. But she responds in a different language. So they're using different interfaces, different languages, which means they can't really understand each other. They can't understand what the other person is saying. So how do we solve this problem? How do we allow Bob and Alice to communicate and to exchange information? Well, we can use a translator. So the translator understands both of these languages. And it takes the message from Alice and translates it into something that Bob can understand, which in this case is aloha. And then Bob is happy because now he can understand it. And he sends a message back, and the translator translates it. So if you think about this in terms of object-oriented programming and design patterns, then this is basically a adapter that adapts from one interface to a different interface. And it maps the same ideas into different messages. So, yeah, so you can do this in programming. All right, so let's go back in time a bit. Let's see how things used to be. I really like this quote. If you watch the software industry backwards, it starts with kids flailing, ends with old guys solving impossible problems by thinking hard. Which is maybe a bit exaggerated, might be a bit of an overstatement, but I think there is some truth to this, because there's not been that much progress in computer science and in software development in the last 30 or 40 years. Pretty much all of the new things that have come up weren't actually that new. So how did things used to be, or when were these things invented? Well, a lot of things were invented in the 70s and 80s. So let's go back to the 70s, to Bell Labs. and see what the folks were up to back there. So who knows who these two fine gentlemen are? Anyone? Any takers? Yes? No, it's Dennis Ritchie and Ken Thompson. So these were two of the main characters behind the Unix operating system, and they were working at Bell Labs around 1970. So they invented Unix. Ken Thompson, this guy over here, is the main guy behind Unix itself, and then there's Dennis Ritchie, who is probably most well known for the invention of the C programming language. So if anyone's programmed in C before, this guy invented it. So here's another picture of those two guys. So this guy is Dennis Ritchie again, a bit older, and this guy is not Ken Thompson, but a guy called Doug McIlroy. No, Doug McElroy, that's how you're supposed to pronounce it. And Doug McElroy was a technical manager at Bell Labs at the time. So what that guy did is he decided to put the Unix pipe into Unix. So anyone used Unix pipes before? Okay. So the Unix pipe. Just a sec here. There we go. So there's this very famous quote by him, which is that the Unix pipe is a universal interface. So if you've maybe heard of Unix philosophy before, then you have all of these different points in Unix philosophy, like programs should be small, programs should do one specific thing, and they should communicate through this universal interface that is the Unix pipe. And so the Unix pipe is this unidirectional channel between processes. So you have two processes right here, one over here, and there's a one-directional channel where the data from the black process, the output from this black process, flows into the white process. And they're completely isolated. They don't know anything about each other. So the Unix pipe is really emerges by how these programs are arranged. They don't have to know anything about each other. So I want to play a little game, and I want you, all of you, to try and guess which Unix utility that is shown on the screen here. So this one, I'm going to do the first one for you, just so you get the idea. This is cat. So data comes in over here and just flows right through. So the same thing that goes into the program goes right back out. It's an echo program. Okay, next one. Any takers? Just shout it out.
T.
Nope. Okay, so this is rev, reverse. So maybe I'm bad at drawing things, but it's supposed to be a mirror, and it kind of gets mirrored over. Yeah? Okay, next one. Yes, grep. So this filters and removes certain things. What about this one? Could be said, but that's not what I'm looking for. Yes, Case. Who was that? Okay, yes, this is Case. And you will see more of Case later on. So, we have all of these small programs that are kind of general purpose. So, well, they do one specific thing, but in isolation, they don't really have a particular meaning. So grep is just grep. It's not grep for a particular string. You need to add that as an argument. And so if you look at this, each one of these lines just does one thing. And only the combination of those things makes it actually meaningful. So what this program does, so this is an example of a pipe where the first command is piped into the second, into the third, and so on and so forth. What this program does is it finds the longest class name in a PHP project. So if you're using Symfony or Zen framework, you're going to get pretty long lines. But the nice thing about this is that you can program on a very high level. So you can write this without having to write actual C code or actual PHP code. Okay, so the Unix pipe is great, and we can now tack programs together. But this is still limited to a single machine. This is not communicating with other people, which we might want to eventually do. So let's bring networks into the mix. And I'm going to represent that using these portals, or ports. So how do we do network programming on the Unix pipe? Well, there's this tool called Netcat. And Netcat, you can think of Netcat as an adapter. Oh, this is the Netcat logo. You can think of it as an adapter from a Unix pipe to a network, to a TCP socket. So, because you've got these two different worlds, these two different interfaces. You've got the pipe world and you've got the network world. And they don't directly map. So Netcat is an adapter between the two. And it looks something like this. So you can have Netcat on one end, sending data, and then another Netcat instance on the other end, receiving data. Now, and if you do this, then you can kind of bridge the gap. So you have a Unix pipe on one machine, and it kind of goes through the network, and then it continues on the other machine. So now you can do all of this stuff that I showed you with the Unix pipe, you can do that over a network, which is already more advanced. Now we can talk to other people, yay. Okay, but Netcat is, especially on the server side, kind of painful, because even if you have a Netcat in a while true loop, it can only really accept one connection at a time. So let's become a bit more sophisticated. So during the 80s, they came up with this thing called INetD, Internet Daemon, which is just a sophisticated version of Netcat that looks something like this. So it's a server-side networking manager. It has a port, anyone can connect to it, and for each connection, it will create a new Unix pipe. It will create a new shell, launch a particular script, any script you want, and then hook up the output from the socket with the input of whatever that program is. So now we have basically a pipe machine or a pipe factory, and it has this nice configuration format. So all you need to do when you want to configure a service using INetD is you give it a name, you give it a port, and you give it a program that you want to run. And then it binds to the port and does the connections. So let's try this. Let's make a fortune command, which just produces a nice fortune cookie message. So just a random message. And we're going to point that to a script in use a local bit fortune. So this is a bash script that we will create. And it looks like this. So it just calls the actual fortune command, and this just produces a random message. And then pipe that through calsay to make it look a bit nicer. And now we can connect to this from a different machine. When you do that, you get something like this. So you get a nice message like, eat right, stay fit, and die anyway, with a cow. So this is what calsay does. It takes any string and wraps it in a nice ASCII cow thing, and you can customize it as well. Okay, so this is cool, but what we really want to do is take some input from the client. That's what useful programs do. They take some input and then do something with it. So let's try and expose calsay itself as a service. So service calsay points it to the calsay binary, the calsay program itself, without writing a custom bash script. So this is the calsay installed by the operating system's package manager. And this means we don't even have to write a single line of bash script. So it's pure configuration. What you can do now is you can take any output, in this case it's just an echo, and pipe that into Netcat. So that will then send it through the socket to the server, and then inetd will hook that up with Case and send the result right back to you. So if you run that, you'll get something like this. So this is Case as a service. Now we can actually take this general approach of command line scripts that read some input on standard in, and we can do pretty much anything with this. So using this general formula, we could parse network protocols. We could write a web server or a mail server exactly in this way, just by reading HTTP messages off of standard in. And as a matter of fact, this is exactly how web servers used to work. So if you look at the old versions of, say, Apache, it was really just a bash script, or a shell script, rather. It was a shell script that read HTTP messages from standard in, and you use something like inetd to manage that for you. So now we're kind of going to the mid-90s, where this thing called CGI came out. And CGI is known as, wait for it, the Common Gateway Interface. So it's kind of like a gateway drug thing for the web. So this allows you to decouple the actual HTTP parsing from your application logic. So say you have a web server that is connected to inetd, and you want to now have some actual application. Well, the application doesn't want to do all of the HTTP parsing itself. You want to decouple that and let the web server handle that part. So what CGI does, well, we'll see how it works in detail, but it gives you an abstract way for communicating HTTP information to this new process. Okay, so it looks something like this. You have inetd doing the networking, passes it on to the web server. The web server only does parsing, doesn't do anything else. Just does parsing, doesn't do networking. It's still using the pipe. And then that goes into a CGI script. And the CGI script is your actual program, which also uses standard in and standard out, where standard in is the request body, and standard out is the response body. And you can send some headers as well. And the way that this works is when the web server passes the request, it produces these environment variables, which look like this. So you've probably seen these words on this side before. This should start to look very familiar now. And the output looks something like this, which you should also be familiar with as PHP developers. But there was one really big problem with this, and that was it didn't scale. Because if you look at it, for every single connection coming in, you need to create one new process for HTTP parsing, and then another new process for the actual application logic. So that's 2 new processes per connection. And operating systems just can't deal with that. It just doesn't work. So that was a bummer, but they fixed it. So how did they fix CGI? Well, they invented fast CGI, which is like CGI, but it's faster. So the way that fast CGI works is instead of creating a new process for every single connection, instead of creating 2 new processes for every single connection, the script itself is now doing its own networking, and the web server is also doing its own networking. So we no longer have this nice Unix pipey stuff going on, but now it's performant. So basically all of the pipes are replaced with sockets, are replaced with network connections, and every single process needs to manage its own networking. Sockets are the new pipes. So far so good? Do you have any questions on this part? Yes? No? All right. Okay, so here's just a brief history of how this went. So, early 90s, HTTP, then you got CGI, then you got PHP, which kind of is based on the same model as CGI, and also was run as a CGI script, as a matter of fact. And then fast CGI to fix it. So they realized pretty quickly that it wasn't going to work. But then after this, something new started to happen. And this is where things get interesting. Because so far, all of these HTTP interfaces were kind of restricted to pipes and to the operating system at this very low level. But then, all of these languages started coming out with their own thing. So you have Java, Python, Ruby, Perl, and they all started implementing kind of an abstraction on top of HTTP, so a way to model an HTTP request and response inside of the language, inside of language data structures. And in many cases, this stuff would then still become CGI at the process level, or FCGI. So that's not gone. But inside of the language, inside of the process, you now also have a way of representing an HTTP request and response. So I just want to look at rack as an example of this. And this is the one that they did for Ruby, okay? So this is what rack looks like. And if you don't know Ruby code, it's not too hard. So it's basically a callable, which in this case is a class, but it could also be a function that takes an environment, and that environment is just a hash, so like an associative array. So this environment contains the actual environment variables. So the same things that you have in CGI with the HTTP underscore blah, 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 blah. You have exactly the same thing, but it's an associative array instead of a global variable. And then the response, which is this thing that in the middle that gets returned, is a tuple or a list of 3 elements. So you have the status code, an associative array of headers, and the response body. So this is just a model for HTTP. And anything you return will then become the actual HTTP response. So what about PHP? Why didn't we have the same thing for PHP? And there is a very good reason for that. And the reason is PHP doesn't need it because PHP already has it built into the language. So what all of these other languages didn't have is the SAPI. And SAPI is a part of the PHP engine called the Server API, which is an extensible system for having different implementations of HTTP transports. So you have CGI, FCGI, all of these different variations of how you can interact with a server or with an external system. You have all of those abstracted, and they all share the same interface. So what does the SAPI actually look like? Well, every time you use a superglobal, every time you use header or echo or exit or set cookie or whatever that stuff is called, you're interacting with the SAPI. So the SAPI just takes some message from the network, depending on the implementation, that will be HTTP or FCGI or whatever, and then transform it into a data structure that is then presented to the PHP user, yourself, as this, as superglobals, generally speaking. Okay, so this brings us to the HTTP kernel interface, and I'm just going to quickly go over what it actually is, since a couple of you haven't interacted with this. So this is a part of Symfony. This is in the Symfony HTTP kernel component. This is an interface that defines how an application interacts with the outside world, or how, from an outside perspective, you can interact with an application. And it's very simple. So it just has a single method handle that takes a request object, and this is a PHP object, and returns a response object. Okay, so is this clear? More or less? Okay, so it looks something like this. You have the SAPI that wraps around the entire application, and this SAPI already abstracts the HTTP implementation. Then you have the PHP process, which interacts with the S API, and then you have the kernel inside of the PHP process. But this is doing exactly the same thing. This is exactly the same thing as the outside layer, exactly the same thing as the S API. So why do we have it? This doesn't make sense. This doesn't make sense at all. It's kind of like this. It's just, there's the same thing in the thing in the thing. This kind of seems wrong. So let's try and find out why we should care about this HTTP kernel interface if we already have the S API, right? Yeah, this slide is usually just around. I think I'm going to skip this time. It's okay. So whenever you ask a Symfony developer why the HTTP kernel interface matters, there's generally two reasons that they will give you, and both of those reasons are wrong. So the first one is usually caching. So for those who don't know, Symfony ships with its own HTTP cache thing, which is basically a re-implementation of Varnish in PHP. So this is an object that wraps around an application, and because you have this handle method and you have a request object, it's actually able to cache those requests and cache the responses and then serve them from the cache. Okay, so caching, just use Varnish. Don't re-implement HTTP caching in PHP. Just use the actual tools that we have. The only reason why you would use that is if you're on shared hosting, in which case, yeah, you kind of lost anyway. Okay, so what's the second reason? Well, the second reason you will usually get is functional tests. So if you have this nice handle method and you have a request object and a response object, what you can do is you can fabricate a virtual request and just you can play pretend. So you can say, let's see what would happen if I were to send this request. And then you get a response. So you can use that in your functional tests, and they generally run not too slowly, depending on what you do in your actual code. Okay, but you don't really need HTTP kernel interface to do functional testing. So just as a proof of concept, and this is just one way of doing it, I wrote this thing called CGI HTTP kernel, which is an adapter from HTTP kernel to CGI. So it looks something like this. It exposes the Symfony kernel interface, so it looks like a kernel. But then on the inside, it will actually create a new CGI process that you can configure, and it will interact with it over CGI. So you can use this with any CGI script, with anything that supports CGI. First, I just wanted to use it to test PHP scripts, any PHP script. But it turns out that you can use this to test anything. So if you have a Ruby script that is CGI compliant, then you can test your Ruby code with PHP. So that's kind of nice. So this just proves that you don't need the HTTP kernel interface thingamajig just to do testing. You can do it without. What's actually kind of nice about this, so here's an example of CGI kernel. You just create a new instance of it, and then you pass it a directory, and that's it. So based on that directory, it will then call PHP on whatever file you request. Now what's nice about this is that Symfony actually ships with quite a bit of testing infrastructure. So you have this thing called the HTTP kernel client, and you can use this to pretend to be a browser. So this is what they generally use in functional testing, except now you can actually use it to functional test anything else. So that's kind of nice. That already gives you some benefit, but this should not be the reason to care about the kernel interface. That's just wrong, because at that point you might as well just go over HTTP directly. So, and there's another problem with the CGI kernel interface, CGI kernel, which is that it's slow, and there's a partial fix for that, which is just to replace CGI with FCGI, and then it's fast. Okay. But where is the actual value? Where is Where's the value of having such an interface? And so what I think is that we've been caring about these things for the wrong reasons. The reasons have been there all along, but we haven't seen them. So the actual value in this, I would say, is in the value objects. So we have an object, a request object, that represents a request. And we have a response object that represents a response. And what this means is that all of that stuff is now locally scoped. Because what were we using before that? Globals. And this, I mean, we already know that globals are bad. This is not news. So that's really where the value lies. Because now everything is locally scoped. You have an object that is actually passed through the system. And you can see exactly which code depends on HTTP and which doesn't. And this is extremely valuable. If you've ever tried to refactor code that just randomly echoes some garbage into your page, or if there's some exit call or some header calls lurking somewhere, it's just impossible, and it's impossible to test as well. So by having a response object, you know that it's not going to just stop execution in the middle of the request, but it's going to actually return you back a nice little object that you can look at and introspect. So this, to me, is the actual reason why you should care. Okay, but there's actually a couple things that I didn't tell you about yet. So for FCGI, there's this concept of FCGI roles, where an FCGI process can be one of these three, or can implement one of these three roles. So you have authorizers, responders, and filters. An authorizer takes a request and either accepts it or rejects it. And if it accepts, then it will go through and go to the actual responder. And then a filter can take a response from a responder and alter that. And what's really cool about this is that each one of these is a separate process, which means that depending on what this service is doing, it can be written in a different language. So say you need extremely high performance for something like a filter, well then you can write it in C or maybe Go. And if you need an advanced logic system to do authorization, then you can write it in Prolog or whatever you fancy. So that's kind of nice because you get a nice isolation and separation of concerns. But this is actually quite similar to something else, which I also didn't tell you about, which is rec middlewares, which is, we'll see what it is. So I want to propose that we adopt the idea of rack middlewares and bring that idea to PHP as HTTP kernel middlewares. This is more or less what it's going to look like. So imagine, okay, I need to explain something first. The HTTP kernel component ships with a default implementation of this. And that default implementation is using the Symfony event dispatcher. So when you make a request against this default thing, it will notify certain events. So you have three main events: the request event, the controller event, and the response event. And you can just bind callbacks to that and then return values. But let's imagine there were more than one implementation of this thing, which there actually are, but most projects are using the default one. Okay, so here's an example of a middleware. This is a class that will wrap around an existing application. And this application can be anything that implements HTTP kernel interface, which is a long word. So it could be a Silex application, because Silex is based on Symfony. It could be Laravel, it could be Drupal, it could be a Symfony app. Anything that implements it will be composable with this thing. So what is this? This is a logger. And it's a simple example, but it illustrates the point. So what this does is it takes an application as a first constructor argument, and then it takes a logger, and it implements the same interface as the application itself. So essentially, it's wrapping around the application, intercepting the calls, and you can now do something either before or after the request. And that's almost the same thing as those FCGI roles, where you can, with the authorizer, do something before the request, and with the filter, do something after the request. We can do exactly the same thing. So it's almost as if we had events without being tied to a particular event system. So how do you use this? Well, given you already have an object $app, which is one of those implementations that I mentioned, then you can just wrap it around like this. So just say application is a new logger of the application. And this is what is known as the decorator pattern. So if you've ever looked at design patterns in PHP, this is exactly the same thing. And actually, Symfony already has something like this. The HTTP cache, I'd remember, use varnish, already works exactly the same way. Exactly the same way, by wrapping around. So this concept is already there in Symfony itself, which is actually not a surprise, because HTTP cache was based on the rack HTTP cache. So all of these concepts from rack are exactly, the concepts from rack produce the rack implementation, and this is just a port of that rack implementation. Okay, so where do I see this going? Well, when we can do a logger like this, then we could do something more interesting. So how about we add authentication, which just intercepts the request and can maybe reject or produce a login screen. And how about we add something like session around it? So this term HTTP kernel middlewares is a bit long, which is why I came up with this name stack. This is just a name. This is just a name that I want to attach to this idea. Okay, so what is stack? Well, it allows you to do something before or after every request. That's basically what it does. You can think of it as a different take on event listeners, and it really is just this very simple set of rules. So if you want to make a stack middleware that can intercept requests, then you just need to follow these three rules. Implement the kernel interface, take an application as the first constructor argument, and delegate to that application in the handle method. And you can do something before or after you delegate. So that's how you intercept things. So I just want to show you a few examples of stack middlewares and what you can do with this. So one of them is the URL map. This allows you to take any application and mount it under a prefix. So say you have maybe a Drupal app, and you want to mount your blog under a prefix, but your blog is maybe a Silex application. Well, with this URL map, you can just say /blog is now my blog. Yeah, there we go. So you just give it a mapping of prefixes and applications or implementations of kernel interface, and it will actually mount it and intercept the request, and if the request URI matches that prefix, it will dispatch to this one instead of the original application. Another one is session. So right now, pretty much every framework ships with their own session implementation. This is a generic one that you can wrap around any Symfony app, and it means that you don't have to have a Symfony and the Silex and the Laravel specific session implementation, but just one single one. This is a proof of concept that I did, which is OAuth authentication. So you can configure it with all of the OAuth credentials, give it a few more options, and it will actually just perform OAuth for you. So have you ever tried to use any OAuth library? Anyone? Yes? Was it fun? So this is a lot easier to use, because you just add these 6, 7-ish lines to your front controller, and that's all you need to do to get authentication, which is awesome. And so sometimes, if you have one of these middlewares that that might produce some information. So in this case, you might get an OAuth username, and you want to communicate with inner layers. So for that, you can use these request attributes. And that's just a part of the Symfony request object. So if you want to get the actual username of this OAuth user in your own code, you can just say attributes get and then the key that was used by that particular middleware. So what's really nice about this is that this is completely composable. You can compose any amount of different middlewares, and they should, for the most part, work cleanly together. And it doesn't depend on a specific framework, because every framework, Symfony has bundles, Laravel has service providers, Silex has service providers. Any framework has its own concept of a module right now. And for some things that makes sense. But for things at the HTTP layer, that really doesn't make sense, especially if you can do something that is more generic and composes cleanly, like this. Okay, so the code samples I showed you with the wrapping application around application, those are kind of hard to read and maybe a bit annoying to write. So there's a slightly nicer way to do that, which is the stack builder. And that's just a little library that helps you configure these stack middlewares in a way that looks a bit nicer. So you can just declare which middlewares you want, just do push, 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 and then resolve, and then you get them all in one go. You don't have to use this if you don't want to, but it's probably a bit more usable. Okay, so I announced this project about, 4 months ago, and we've already got a bit of community around it. So there's already quite a few middlewares that you can already use today. Here's just a couple of examples. Backstage is an interesting one. So Backstage, you configure it with a file name. It checks if that file exists, and if it does, it just includes the file and exits. So this allows you to, it basically allows you to have a nice maintenance page. So when you need to take your website down for some upgrade or something, then you can just create the file, and once you're done, delete the file again. And you can add this with one line of code. So I think there's quite a bit of potential out there for things that you can do this way. And here's just a couple ideas, but I'm sure you can come up with your own ideas as well. So authentication is probably the big one, or just general authentication authorization stuff, where right now there's really no good solution for that, I'd say, at least no good generic solution. There's lots of framework-specific ones, but there's no generic approach to security. And this works really well at this layer. So I'd like to see some more work around that and have some actual usable security systems, because frankly, I'm sick of Symfony security. Okay, so these are a couple of the implementations of HTTP kernel. These are the ones that already support it. Drupal is kind of broken in this regard. Blame Larry. No, it's his fault.
Blame our legacy code we haven't gotten rid of yet.
Yeah, it's not your fault. But yes, work in progress. And there's actually quite a few more that I didn't list here. Go to the Symfony website and they have an entire list of things. But I mean, if you're using a framework that supports it, you probably already know that it's based on Symfony. Laravel 4.1, which is going to come out in 2 weeks or 1 week, I think, will actually ship with some middlewares already. So what they did is they took some of their own things, which is, I think, cookie encryption or cookie signing, which they had as a general feature, extracted it as a middleware, and now you can install it standalone. So that means you can use the Laravel cookie signing thing with your Silex app, which is really cool. So I'm really happy that they decided to adopt this and try and push it a bit more. So I don't think everything makes sense at this layer, but I think there is a lot of potential. And that's basically it. I'd say go stack some middlewares and I'm ready to take some questions if you have some.
On va aller vite sur les questions.
Actually, I've got two questions.
Go ahead.
The first one is, well, Stack is based on the HTTP kernel interface, but it's starting to be used by a lot of projects. Is there any plan to propose a PSR about it?
So there was a PSR to give generic HTTP messages. I don't think it really went anywhere. I don't know. To be honest, I've kind of lost the hope in Fig, but we'll just have to wait, I guess, and see. So if there were to be a generic HTTP interface that is used by different frameworks, so that Zen framework would also participate in this, that would be completely awesome, because then we could also use these things with Zen framework and other frameworks as well. Because yes, as you say, it is kind of limited to Symfony right now. But I don't see that happening anytime soon. I think we'll just have to wait and see if any consensus will ever arise.
A second question, quickly. Is there any kind do you think you will add there will be support in React PHP for Stack?
No.
Is there any sense to do that?
No. The problem is Stack kind of requires that you have a synchronous way of doing things, because HTTP kernel synchronously receives a response. So if you want to do any non-blocking operations, then you can't really return anything. So you need to return by doing a callback. But even if you were to do something like HTTP kernel that is asynchronous, it still doesn't really work that well, because then you would have to return the entire response in one go. There are some asynchronous things for for rack in Ruby, but it's really an awful hack and doesn't work that well. So I'd rather just not go there. I don't think there's an easy way to do that. Does that answer your questions? Okay.
Dernière question.
Do you think it would be benefit if PHP provides request, get, post, and so on as objects?
Yes.
Merci beaucoup.